That's going to tell us if we're dealing with a rectangle or even a square. We can use the diagonals would be congruent. The midpoint formula is to tell if the coordinates, find the coordinates of the midpoint of side, or tell if the diagonals are going to bisect each other. We're going to use the midpoint. We're going to find the midpoint and then try to identify what type of shape we're dealing with inside of a figure. And then lastly, the slope formula, we just take our difference in our y's over our difference in our x's. That's going to help us determine if sides are parallel possibly, or if diagonals are perpendicular, or if sides are perpendicular. So we've introduced some concepts with slope. You've also talked about slope in Algebra 1, where if your slopes are opposite reciprocals, that means that your slopes are meeting at 90 degrees. If your slopes are exactly the same, that's going to mean that you're dealing with parallel lines because they're going at the exact same rate. So starting to apply some of those things that we saw in Algebra 1 into some of the figures that we are starting to see in geometry. As I use some of these formulas, I'm going to use a graphing calculator. You can get to a graphing calculator anytime by clicking on the icon on our schedule. So on each page of our schedule, you're going to have that graphing calculator icon. So if you click on that, that'll open up our graphing calculator, and we can open up. It's going to kind of look like we're heading into an MCA test. We can just keep hitting start until we get to the main page, and then if you click on that calculator button there. I'm going to see if I can get this to go side by side here. And all right, there we go. And then we'll head into now our practice sheet here. So in numbers 1 and 2, we're going to determine whether or not the triangle that we're dealing with is scalene, isosceles, or is it going to be equilateral. So we're going to check each of those and determine what type of triangle that we are dealing with. And in our first problem here, we've got X, Y, Z. We've got 3 different sides of our triangle that we're going to determine. Now, scalene, we have to recall scalene means that all 3 are different. Isosceles means that 2 are congruent. And then equilateral means all 3 sides are congruent. So when we're classifying, that's what we're looking for, determining whether or not our sides are going to be congruent or not. That's what we're looking for. All right, so I got to figure out, okay, what's the distance between X and Y? I got to find out what's the distance between Y and Z. And then I'd have to figure out what's the distance between Z and X. And then I'll check out if all 3 of them are the same. Okay, then that would mean that it's equilateral. If 2 of them were congruent, then it's isosceles, excuse me. And then if all 3 were different, then I'd be dealing with a scalene. So from here now, we're gonna go ahead. Let's find out what is our X coordinate at. So our X coordinate would be at 4, 2. Our Y coordinate is at 2, -2. And our Z coordinate is at -2, 0. All right, so there we've got our 3 coordinates. Now we're going to start using the distance formula to determine how long are these sides. So looking at it, I mean, I would say just looking at it, it looks like it's scalene to me, but I can't just assume anything. I can't just assume that it's scalene just because of how it looks. So I do need to use the distance formula. So I'm going to use the distance formula first between X and Y, then between Y and Z, then between Z and X. So here's where I'm going to pull out my graphing calculator to use the distance formula. So using the distance formula, I am going to use the square root button. So I'll show you where that is. And then we're going to take the difference in the x's squared of our 2 points plus the difference in the y's squared between 2 points is how we're going to find using our distance formula. So first, the square root button. So square root button is something that we're going to use a lot in this section and continuing throughout your math careers. It's where the x squared is. So diagonal from the 7, you're going to hit second, and then that square root button. If you're using the online calculator, or if you're using the latest software, if you have like the color type calculator, your calculator will have the latest software where your square root is gonna kind of follow along and is gonna put everything that you're putting into the problem underneath your square root. Some calculators you gotta watch out. You might need to use parentheses to group things together, but most calculators have updated their software, so you don't have to worry about that anymore. So first, we're going to find the distance between x and y. So x and y are going to be these 2 points, 4, 2, 2, negative 2. So I'm going to start by opening up a set of parentheses. We're going to do our difference in our x's squared. So 4 minus 2, close off my parentheses. My square button is the same button I use for the square root, diagonal from the 7 there. So there's going to be my difference in x's squared. Then I do my difference in y squared. So adding my difference in y squared, which is going to be 2 minus a negative 2 squared. So there's going to be my second option. If you want, you can put that negative 2 into parentheses. That's fine. Close that off. That's going to work as well. But there's going to be basically my distance formula. I've done the 4 minus 2 squared plus 2 minus a negative 2 squared. This is a little bit different than the slope. It doesn't matter which order you use. So if you started with the 4, 2, it doesn't matter if you'd start with the negative 2 in the other one. It's all going to work out because when you square a number, it's always going to be positive. But now we're set to find our first distance. I hit enter, and I get about 4.47. So I'm going to write down 4.47. That's going to be roughly my distance between those 2 points. Okay. Heading into my second one. So now I'm going to find the distance between y and z. Now typing this in, it took me a little while to type that in. Here's a little trick you can do with your calculators, and most calculators have the latest software that can do this. If you hit the up arrow, it's going to go what's called your history, and then you can hit enter on that, and it's going to pop it down into your next line. So now you don't have to go back, hit square root, hit squared. All you have to do is just go in and we can change the numbers. So now we're doing from y to z, where here was my x points, 4 and 2. I'm just going to change those to z points. So z has an x coordinate of negative 2. So I'm going to hit second insert, which is second delete, put in negative 2, and then we're going to delete that. So negative 2 minus 2. And then I'm going to put a 0 in for my y point. So remember, this 2 right here was the y coordinate of my x. So I'm going to put a 0 in for that. And we get our next distance, which ends up being 4.47. So far, we've got a isosceles triangle. We're going to check the last one to see, is it equilateral? And we can't just use the eye test. We do have to prove it. So we are going to find out what's the distance between z and x. So again, I'll go up, I'll grab the same problem I just did, pull it down, and now the negative 2 and the 0 are my z coordinates. So I'm going to now put in my x coordinates. So I'm going to go in for my x value of my x point here is a 4, and the the y coordinate of that x point is a 2. So I'm going to have to delete some stuff here. Just delete that negative. Now I have a 2 there. So now we're set up. We've got the z coordinate is negative 2, 0, which are those two numbers. And then the x coordinates are negative 4, 2. I'm using that point right there. So you can go up, you can grab the previous one, so you can kind of have some of the stuff typed in, then you can retype in the new point that you're using. But anyway, we'll hit enter, we'll see what we get. And there, yes, it did look like it was a little bit longer, and it is, it's 6.32. So all in all, for this one, we're going to get that this one is scalene. So scalene is going to be what we get for this type of figure. We'll head over here. So check this side, check this side, check this side. Once you get all three sides checked out, you would be able to determine what type of figure it is. The second thing we're going to do is just talk about the midpoints. So we're going to check out the midpoints of these figures, of this number 3 down here. Once we find the midpoint, we can construct a figure, and then we're going to determine what type of quadrilateral. So a midpoint is going to be the direct middle of a segment. And to find the midpoint, what you can do is you can use that midpoint formula, but you can also just find the halfway point between your x's, which would be right here, halfway point between your y's, which would be right here. So that means my midpoint is right here. So you're going to find that halfway point between your x's, find that halfway point between your y's, and that's going to be where your midpoint is. So that means I have a midpoint up here. So now checking out over here, my halfway point between my y's is right here. Halfway point between my x's is right here, which means my midpoint is right here. And then I would construct those two. Now I'm ready to construct my figure. I've got a polynomial or a quadrilateral that's forming inside of here. So now we're going to check out that quadrilateral. We'll get all this extra stuff erased. And taking a look at it, it looks like my slope between this point to this point is the same as this point to this point. So I've got parallel lines there. And then these are just straight vertical, so those slopes are the same. So what's the most precise? I have a parallelogram in this case. So here I've got a parallelogram happening. I can tell that by the opposite sides are going to be parallel, which is going to be the most specific I can get is parallelogram. So in each of those remaining cases, we're going to go through, find the midpoint of each of your sides. So heading here, I can see there's my midpoint, there's my midpoint, there's my midpoint, there's my midpoint. Then I can start to construct out my figure and then start to figure out, well, what type of shape did I construct when I get all those figures? And that looks like, to me, that would look like it would be a square because all four sides are equal. And you get the 90 degrees as well. So that'll kind of test using slope, using midpoint, and checking to see what type of figures we see forming there. Well, that brings us to 832. So we are ready to break off to work on section 6.7. If you have to stick around, if you need any clarifications with the calculator, I know I kind of went through that kind of fast. I can help you with that. But you are free to go. Have a great day, and we'll take a look at section 8 tomorrow. Have a great rest of your day if you're taking off to work on your own.